All right, thank you everybody for joining us, and thanks Matt for that super groovy music. That was great. If things get a little slow in the QA afterwards, maybe we'll open up for some scat solos. I am Mike Raley with Pack International. We've got some questions already in the chat going on about who was that band and everything like that. So we're gonna start off. We just wanted to get a little better handle on who's here, who we're talking to. We might sort of tailor some examples as we go through the presentation. So thanks to everybody that participated in this little survey. Looks like we've got a fair few acousticians here. Makes sense as an INCE presentation, but some architects, contractors, and others as well. So thanks everybody that did that. And I think now, let's see, I'll click my little button here and move on to the next slide. So this presentation is, we're covering a hot topic today. This is titled, Don't Let Your Good Sound Isolation Go Up in Smoke, brought to you by or sponsored by Maxxon and Pack International, and of course, presented by INCE USA. Few little blurbs here about INCE to start things off. Thanks so much to INCE for letting us do this and for putting on this webinar series. I think it's a really great thing. All of the sort of education training things that INCE is doing. They've had their INCE board certification that certifies that people know what they're talking about with acoustics. That's a really big deal. A great thing for our industry. Now they're also working on like technician certification programs. They're putting on these webinar series, and they also have their conferences that they do yearly. So the next one coming up is NoiseCon, May 15th through 18th in Grand Rapids, Michigan. It's co-located, co-done with SAE. So there's a lot of automotive NVH stuff going on there. They're always great. There's big exhibits, so there's a lot of manufacturers there that you can go to see the latest and greatest products and innovations. There's a lot of great presentations. There's other meetup groups and things like that. There's the women in engineering and acoustics luncheon. There's a bunch of different things like that. It's a really great place to go learn, network. I know I always learn a lot when I go there, so please check that out. Support INCE. And if you're not already an INCE member, it really is a great organization to be a part of. Go check out their website, inceusa.org. Great organization for acoustics and really helps promote the industry in the field and educate everybody. So it's a really great thing, and we're really happy to be a part of this. And with that, I think I'm going to turn it over to Heidi with Maxxon to talk about one of our sponsors today.
Wonderful. Thank you so much, Mike. And good morning or good afternoon, depending on what coast you are on. My name is Heidi Larson. I am the West Regional Manager for Maxxon Corporation. And for those of you who don't know about Maxxon, we are the manufacturers of gypcrete floor underlayments and Acoustimat sound control mats. So just real quickly, who we are. The background of Maxxon is really a story of the history of gypcrete. So back in 1972, two brothers, Clyde and Ron Jorgensen, really revolutionized the construction industry with the innovation of gypcrete as a replacement to lightweight concrete and multifamily wood frame construction. So in 1995, the Gypcrete Corporation became Maxxon Corporation. And by that time, we had multiple Gypcrete products, self-leveling underlayments, and Acoustimat sound control products. So the Maxxon name really allowed us to expand our product offerings under one umbrella. So today we have over 6 underlayments, including some pre-sanded options. We have self-leveling underlayments and 8 Acoustimat or 7 Acoustimat control products for sound isolation. So again, just looking at our product portfolio, we really tried to provide the solutions for the floor ceiling assembly when it comes to sound isolation, fire performance, and also moisture mitigation and any solutions that we can provide with problematic slab repair. I'm sure Evelyn will get into this, but we are very excited that we have developed a state-of-the-art acoustics chamber in our corporate headquarters back in Hamel, Minnesota. It's a great endeavor for us, and we are looking forward to getting numerous sound tests out of that chamber. And then we do have a robust, dedicated R&D team in our corporate office in Hamel, Minnesota. So just taking a quick glance at our product portfolio, this is a quick overview of our gypcrete floor underlayments. So when you look across the line, starting with our gypcrete basic, this is an underlayment product, again, fire rated, ideal for multifamily construction up to 2200 PSI. And as you look across the portfolio, we increase in compressive strengths about 1000 PSI from one product to the next. So depending on what your compressive strength demands are or specifications are, we do have products to meet a variety of different PSI ranges. And then looking over to the Acoustimat products, again, Acoustimat sound control mats are really designed to help increase your IIC sound performance in wood frame construction when it comes to areas where you have a hard finished floor covering and you need to increase your IIC ratings. Again, on the Acoustimat line, we have a variety of thicknesses available from an 1/8 inch Acoustimat all the way up to a 3/4 inch sound mat. Your thickness of your gypsum concrete depends on which sound control mat you are putting into your building. As you can see, there's a few products that have a premium designation underneath them. And what that means is we have a premium version of these sound mats with an additional acoustical fabric on the bottom side, which again enhances your IIC sound performance over the regular version of the sound mats. For anything that's a concrete renovation or you need a thinner application, we have Acoustitop, which can be used for high compression areas, or also used as a joint system with our encapsulated sound mat to increase your sound performance. We do have some commercial pro floor underlayments. These are higher strength products, primarily designed for concrete construction and renovation, but just to give you an idea of our full product portfolio. And then again, we do have our pre-sanded products, again, for maybe multifamily renovation, where you have to come in and repair an existing lightweight concrete or gypcrete floor. We have these pre-sanded options that are 50-pound bags, again, still meeting the fire performance and also the acoustical performance aspects of your floor assembly. So again, why Maxxon? We've been doing gypcrete floor underlayments and acoustical solutions for well over 50 years. We have a product portfolio that can help you in virtually any floor ceiling assembly. Maxxon is based in the US and all of our products are produced here in the United States. So we are an environmentally friendly company that will help you guys design your projects and also help contribute to any type of LEED credits that you need. So that wraps up for the Maxxon portion of it. I am now going to hand it over to our partner sponsor, Steve Sourich from PAC International.
Oops, hit the button too quick. Thank you, Heidi. Thank you so much. My name is Steve Sourich. I'm PAC International Sales Director. And talk a little bit about who we are. PAC International has 40+ years in the construction industry and over 20+ years in manufacturing noise control products. And that was all started by Elzo Gernhardt, who created the original RSIC, we call it RISC 1 sound isolation clip. And we've continued to develop products. We have 75 and counting now in our product line. And we've developed a lot of these products through working with customers who came to us with a particular acoustical challenge. And then we figured out a way to develop a product that would meet that challenge and solve the problem for them. So that's how our product line has grown over the years. A little bit about PAC products here. We've got obviously the RSIC1, which most of you are familiar with. This is the original, and there's some copies out there now, but we've, this is our bread and butter product we've been selling for, again, over 20+ years. We have 174 UL fire resistive designs, an extensive online database, which I'll talk about here in a minute, of acoustical testing and so forth. And this is the go-to that we try to push everybody to get away from things like resilient channel, which we're all aware of the limitations of that particular product. The way we approach, our product development is by looking for solutions to common problems with a lot of our products, or a lot of the acoustical solutions that are out there, I should say. And so we've tried to find a solution for each part of the market, starting with our, with resilient channel, which again has been around forever. We all know the limitations. We've developed a product called the RC1 Boost, which is designed to get you up over that, that code minimum hump, which oftentimes RC by itself won't do. And it's a very simple product. that you guys can find information on that product on our website if you want more information on it. And of course, RISC 1, which is again the standard that that's the 74 plus products or 75 plus products we have. There's a lot of versions of this particular type of isolation that we've adapted for different construction, different assemblies, different attachments, and so forth. And then, we recognize that people always have, cost whenever they're looking at building, and they're trying to balance cost against acoustics. So we develop products that fit niches in between, like the RISC V, which is a more economical version of the RISC 1. We've got rid of the rubber damper, but you still get yourself over code. Likewise on ceilings, a lot of these products, again, are good for floor ceiling assemblies and for wall assemblies. RC1 Boost has shown really great promise in testing, especially for impact noise. And we've been able to get a 5-point increase on any resilient channel on a ceiling application. So that's a great way to bump that IC number up and get you some cushion there, which, as everybody knows, the IIC code minimums are exactly that. They're too low, and everybody knows in this industry we got to get them up higher. And of course, RISC 1, which again, bread and butter. We've developed another product in here, which is a hybrid of our RISC 1 clip called the RISC SIX, where we've introduced a spring to it with the eye of finding a sweet spot between full springs and the RISC 1 to give us, again, something that fits. We're calling it more better here, something that fits in between those two, because full springs, as we know, that's the ultimate, but we also know that that's also the most expensive thing on the market. So it's a great newer product that we're still working on more testing for that product. And we've found that it's providing some additional low frequency performance. And so we're still trying to figure out where that fits exactly, but it's a good midpoint. Lastly, I'm going to finish with just a little bit about our website. We have a ton of resources on our website. If you go there right now and just looked at it, you're going to see, we have a product selector, so you can look at all of the 75 plus products we have here. You can look at information on each one of them, submittals, and then you can actually select by assembly type. You can look at whatever type of assembly and see which product we fit to a particular assembly. We also have a UL fire rating selector here. So if you're coming in looking for a fire rated assembly, or your UL number, you can look it up and see if we have a product that's been tested on that, or you can select from the left on the left using the filters based on the assembly type you're going to be that you need, or the particular pack product you're going to be using. If you take it a step further and register for a free login, that will get you access to our assembly selectors. We have a selector section set up for architects. We have a selector section set up for acoustical engineers as well. This is just an animation showing how you can get to the data that you're looking for a particular assembly. Again, you can filter by all of your different assembly constraints and components, and find, look up those resources that you can get to the test reports and so forth for those assemblies. So it's been a really handy tool for us. And if what we'll try to do is put that link up in the chat here at the end or in the Q&A. I'll try to get that up there, or one of us will get that up there. So if anybody wants to register for our site, please do. Lastly, if you don't find what you're looking for, and I think this is something that's key about PAC International, if you don't find what you're looking for, contact us, give us a call, send us an email. Our staff, again, we have 40 plus years of construction experience and acoustics. Mike Raley is our INCE board certified acoustician. He's on staff, and we're ready. We're all sitting here ready to answer questions. I spent 14 years with Quiet Rock, so I've been around acoustical products for quite some time. So with all of our different team members, we're here to help you guys find a solution for a particular acoustical challenge that you're looking for. And with that, I'm going to turn this over to Evelyn Way from Maxxon, and thank you.
Thanks, Steve. So now we're going to dig into the nitty gritty, or the more nitty gritty. We're focusing today on the intersection of acoustics and fire ratings and how they work together and how they interact. Just a quick overview of what we're going to talk about. We're going to hit some of the basics of acoustics. We're going to hit some fire rating basics. And then the devil is in the details. We're going to talk about how that single number, whether it be fire rating or an acoustic metric, tells you something, but doesn't tell you everything that you need to know. And then we'll look at how all of those interacting parts create tension on the design team, and a little bit about rule of thumb, and then we'll get into some examples for of different ways that acoustics and fire ratings interact. So just to start with, to give us all some context, there are some code requirements for multifamily residential for acoustics. Those are lab numbers STC and IIC 50 for airborne and impact sound. And then in the field, 5 points less, which allows for both flunking and construction tolerances. Here you see NNIC and NISR for the airborne and the impact ratings. You may have seen that those are the what is in the latest 2021 ICC code. You may see different metrics in different markets. That still, once it gets passed on the national level, it has to filter down into each state and municipality. And so sometimes you're still going to see AIIC and ASTC for apparent sound and impact transmission. If you've been around a really long time, you may be familiar with those metrics as FSTC and FIIC, with the F standing for field. So now there's a code minimum for you. We've put a line in the sand, but is that good enough? And in fact, some people say that a large percentage of people are still highly annoyed by noises from their neighbors at this level. And who is it that said that? It is the ICC themselves. So in 2010, they set forward another set of guidelines with an acceptable and preferred level. You can see that the lab ratings for that is 55 is acceptable and 60 is preferred. We kind of think of those as, you know, the acceptable is high-end rental, and the 60 and above or 60 is good for owned units, condos and the like. So now I'm going to pass it off to Mike, who's going to tell us a little bit about fire.
All right, thanks, Evelyn. So fire ratings, just the very basic, right? We typically talk of, you know, 1, 2, 3, maybe 4-hour fire ratings. But what do those really mean? And when I started into this, I'd heard them, you know, working as a consultant. I said, oh, you know, between these 2 units for our demising wall, we need a 1-hour rating. But what does that actually mean? And basically, it just means that wall or floor ceiling will stay there in place theoretically for that amount of time, which gives people time to get out of the building, and also hopefully gives firefighters time to get into the building to help rescue people, get them out of the building, and also help hopefully put out that fire. But it doesn't mean that, you know, the thing won't burn down eventually. It just means there's enough time for people to get where they need to go. And so that's why you'll see higher ratings, you know, like a 2-hour rating typically for, you know, exit corridors, stairwells, or even in bigger buildings or certain things like that, you might see even higher requirements. Years ago, I worked on a project where they wanted to build an extension and expansion of a hotel building on top of a parking garage in downtown Portland. Well, that whole floor ceiling assembly between the hotel and the parking garage needed to be 4-hour fire rated, and there was a whole bunch of other things that needed, you know, 4-hour fire ratings. And surprise, surprise, that one didn't pencil out. So that's kind of the basics of these fire ratings. But then, come on, button. My pickle is not working. There we go. Thank you. So how do we get those fire ratings? So for the fire tests, we have, they're done in a similar fashion to the acoustical test for those of you that are familiar with those. So we have a test chamber. In this instance, it's a big furnace. right? A specialized furnace. And there's an opening on one side of that furnace. And in that opening, we build the assembly that we're going to test. So that might be a floor ceiling assembly or a wall. And then basically you set fire to it. It's obviously a little more complicated than that. We have this standard time temperature curve. And so this is how the temperature in that furnace increases and changes over time. And there are different pass-fail criteria that they're looking for that determine the hour rating for an assembly. So one is excessive temperature rise. So there are thermocouples that are placed throughout the assembly, both within it and on the non-fire exposed side. And they look at the temperature rise, and there are criteria for how much that temperature can go up for the assembly to meet the 1 or 2 hour rating, whatever you're going for. Passage of flame is another fail criteria. Obviously, if the fire starts burning through the assembly, that's no good. If it starts getting to the structure, that's no good. That would be a failure. Structural collapse, obviously another failure, right? Unlike the acoustical testing that we do, a lot of times when you do a fire test of like a load-bearing wall or a floor ceiling assembly, the assembly is actually loaded for that fire test. And so it would be loaded to the design load or maybe some percentage of it. And so if the structure starts to degrade because of the fire to the point that it can no longer hold that load, it fails, and obviously you don't pass the fire test if it fails before whatever hour rating you're going for. And then the last one is specific to walls, and that is the hose stream test. So after a wall is burned, say for an hour, it's removed from the furnace, and then they spray it with a fire hose. And they spray the side that was exposed to the fire, and usually, that gypsum board or whatever, because it's been burning for an hour or more, that falls off. But the criteria is that the hose stream can't go through the other side of the wall. So those are your pass-fail criteria for how you get these fire ratings. All right. So now let's talk a little bit about the devil is in the details and talk about acoustics here. So a lot of times when we talk about acoustics or fire ratings, we talk about single number ratings, right? And SDC or IIC ratings. So here we have 3 wall assemblies that meet the code minimum of SDC 50, but they're all very different assemblies. The top left, we have a basic 2x4 wood stud wall with resilient channel. On the top right, we have a double stud, double shear wall. Those brown lines on the inside are shear panels. So we create this small interstitial airspace. And then on the bottom left, we have a CMU block wall, right? All SDC 50, but do they really perform the same acoustically? Like, do they sound the same if you're on the other side of it from some particular noise source? And are they the same for fire? Of course, the CMU block is not the same for fire as a 2x4 wood stud. But what do these do acoustically? So here we have a table with, for the acousticians on here, you're used to seeing these kinds of things. But for those of you that aren't familiar with these, on the x-axis or the horizontal axis, we have frequency in hertz. And that goes from low frequencies, low notes on the left-hand side to high frequencies on the right-hand side. And then on the vertical or the y-axis on the upper chart, we have the TL or the transmission loss of the specimen at those different frequencies. And the transmission loss is basically just the amount of noise reduction that you get from one side of the wall to the other at those particular frequencies. And then on the bottom, we have the deficiencies, and that's basically just how much the measured transmission loss is below this curve that's specified by the ASTM test standard. So you can see the basic takeaway from this is that they all have the same STC rating, STC 50, but if you look at the 3 different colored lines that correlate to the 3 different walls, you see that the TL values at different frequencies are really different, right? So the CMU block wall in green provides pretty good low frequency transmission loss, but it doesn't increase much with higher frequencies. So the CMU wall is the best at low frequencies, but it's the worst at sort of mid frequencies. Whereas the double stud, double shear wall does really well at mid and high frequencies everywhere from 250 hertz and above, but it doesn't do nearly as well at low frequencies. So the point is, even though all of these walls have the same STC rating, if you were standing on one side of them with the same noise source on the other side, what you would hear would be very different. And so when we're designing for specific uses, like maybe a band performance hall or something like that, this low frequency matters more, we need to pay attention to more than just the overall rating. All right,
So-
Evelyn?
Thanks. So, before I get started, we were going to mention earlier, feel free to put any questions as we go along into the chat and the Q&A, and we'll address them. We've allowed ourselves plenty of time at the end to deal with questions. So if we look at floor ceiling assemblies, all of these three are the same IIC. They're all IIC 60, but are they really? And obviously, they're very different in how they'll interact with fire. The two on the top would probably be a 1 hour tight assembly, but the concrete one would be based on the thickness of the concrete slab. But we can see that the STCs are a little different, and also that the HIIC, which is a metric that evaluates just the high frequency impact noise, those are really quite different. The analogy that Mike and I have been throwing around is that you can have Nirvana at 70 decibels, and you can have Beethoven at 70 decibels, and you'll have a very different experience listening to both of those. And so obviously we'll have a very different experience on the other side of this floor ceiling assembly from whatever noisy thing is happening. And here again, we have our chart with our full data on it. The blue line and the red line, the cavity assemblies are relatively similar, all they kind of weave in and out of each other. The green assembly, the concrete one, is lower at pretty much all frequencies with that slab and the floating floor assembly. So that while they still all have the same single number rating, they are going to be different acoustically.
We have a similar sort of thing for fire, right? So typically for fire, one of the most common references that we use for the fire rated designs to figure out how do we build a 1 hour wall or floor ceiling assembly is we will go to UL, the Underwriters Laboratory, and they have a list of all of these different fire designs for all different types of construction. So here's an example, UL U465. Now these are prescriptive designs, but within them, they're sort of a choose your own adventure, right? So for each of the different elements that make up the assembly, you're often given a lot of different sort of options to pick from. So there's options in a steel stud wall like this U465. There's options for the gypsum board that you use, and that might be the type, thickness, and manufacturer. There's also options for the insulation. There's options for the studs and how the gypsum board is attached to the studs. So the three options that you have here all meet the design intent of U465, but you can see that they provide very different acoustical performance. So on the right, we have two walls, essentially the same basic building elements, but the difference is the thickness, the mill thickness of the studs and the spacing of the studs. And that can make a significant difference in the acoustical performance, but it all still complies with that design of U465, because often the way like studs and things are specified in these UL designs is they're specified as minimums. So from a fire standpoint, and we'll get into this a bit later, if they provide a minimum, right? So the minimum might be a 25 gauge 18 mil steel stud. But if you use thicker, stronger steel, that's great from a fire perspective. So that's, still meets that 1 hour design intent. But acoustically, it might have other implications. On the left, we have another wall, still meets the design of U465, but there's additional gypsum board. We have isolation clips to isolate the gypsum board from the studs, and we get much higher acoustical performance. So on a project, if you're specifying walls, specifying U465 for your fire design might get you where you want, but it's not necessarily going to determine any sort of acoustical performance, because there's a wide variability of the acoustical performance for walls that meet that design intent. Similarly, you have this for floor ceiling assemblies, and there's quite a bit of variation in these as well. And oftentimes for the fire design, things are given in terms of minima or maxima. So here is an example, L546. Again, all of these meet the L546 design, but acoustically, they perform very differently. So on the right, we have ones with resilient channel. The one on the top has no finished flooring, gypsum concrete poured directly on the subfloor. Not bad STC, the IIC is well below the code minimum. On the right, we've got a mat beneath the gypsum concrete. We have finished flooring and underlayment, much better IIC rating. And then on the left, we have a very robust system, right? With higher performance ceiling isolators. We have thicker gypsum concrete, a thicker underlayment beneath the gypsum concrete, and much higher performance. But again, the point here is that all of these comply with the UL design, but their acoustical performance is very different. So when you're specifying walls and ceilings on a project, you have to go beyond just the basics of, specifying single number ratings for acoustics and, just the basic UL designs. And that's really where we get into this tension in the design team, because as acousticians, we want certain things, but then the fire design engineers want other things. And sometimes those things work together, and sometimes those things are at odds with each other. And oftentimes we're both at odds with the money man. And Evelyn's going to go into a little bit more of some examples of sort of where that tension comes into play.
Play a little role-playing exercise here. We've got our developer who only thinks about money, our structural engineer who doesn't want the building to fall down, our fire protection engineer who's very interested in how the building's going to hold up in case of fire, and our large-eared acoustician. And all of them have different needs. So for on resilient element spacing, resilient channels and the like. Our developer wants wider spacing, fewer of them because it's cheaper. The structural engineer and the fire protection engineer want narrower spacing so it holds up better. And our acoustician wants wider resilient element spacing. Looking at how many layers of gypsum board, in this case, the developer wants fewer of them, it's cheaper. Our structural engineer wants fewer of them, it's lighter, he has to design for less load on the building. The fire consideration wants more layers of gypsum board, and more layers of gypsum board give us a better sound isolation performance. So looking at stud spacing, again, let's pay for fewer studs, shall we? The structural engineer wants a narrower spacing in order for better structural integrity. Narrower spacing helps with fire resistance as well. And in fact, wider stud spacing gives you better acoustic performance. So there's some good conflict there. And lastly, screw spacing. Let's pay for fewer screws. Let's have wider screw spacing. The structural engineer's a bit ambivalent about it, but definitely for fire you want narrower screw spacing, and for acoustics we want wider screw spacing. So what are we to do with all of this? Well, we could give you a bunch of rules of thumb that you could take back and apply to your design, but those are dangerous. And so instead, we're going to send you to some experts. Both INCE and NCAC have good directories of acoustics consultants. NCAC is only consultants. INCE will also, has a broader membership. And you'll find manufacturers. It's a good way to vet manufacturers, and the information that you're getting from them is to see INCE membership and INCE board certification. So here's an example of where rules of thumb can trip you up. So we all know that adding insulation to a cavity increases the acoustic isolation performance. So we get 8 points STC and IIC for adding 3.5 inches of insulation in this wood joist assembly. This is a 2x10 or 2x12 assembly. Incidentally, this data comes from a publication by NRC testing labs in Canada. However, let's say we want to go all in and we want to fill the full cavity full of insulation. So for our 2x10 assembly, we get another point or two by filling the cavity. In our I-joist, they're showing that we're going to get 3 to 5 points with a full cavity of insulation. That is, however, an 18-inch I-joist. So how much acoustic performance you get when you fill a cavity full is dependent on how the full depth of your cavity. So just putting a rule of thumb and a simple answer on it is a risky move. And so Matt's going to go into some examples that are going to tell us why those rules of thumb can be even riskier.
Yeah. So the first example I'll start with is insulation thickness versus resilient channel spacing. And I think just generally, in acoustics, when you ask a question, often the answer is, it depends, right? It depends on the context. Well, this example is sort of one of those, right? So we're going to take a UL design L587. And within these UL designs, there's something that I wasn't aware of in detail when I was working as a consultant, and I learned it since really coming to PAC and being schooled by Elzo. But the channel spacing, either resilient channel or like hat channel and clip spacing, is dependent often on the insulation thickness and placement and type for that matter. So we'll run through some examples here. So we'll start off at the top left. We have a typical open web truss, and in this case we have no insulation in the cavity. So we can space our channels up to a maximum of 24 inches on center. When we add insulation, if we do it tied to the subfloor, right? So up the top part of the truss cavity, and we have a maximum of 3.5 inches of that insulation, then we can space our resilient channels, or again, hat channels and clips, at a maximum of 16 inches on center. If instead we place that insulation, the same 3.5 inches of insulation, directly over the resilient channel and the gypsum board ceiling, we have to reduce our spacing down to a maximum of 12 inches on center. And at first, when I started learning about this, it didn't quite make sense to me. But then it was explained that the fire is burning from below, right? That's, flames tend to go up in the furnace. When you do the fire test, the fire is below the assembly and it's burning against the gypsum board ceiling. So that fiberglass bat, it's thermal insulation, right? It's there to resist the movement of heat from one side of it to the other. Well, when you have that over the gypsum board in the fire, it traps more of that heat from the fire at the gypsum board, which makes the gypsum board heat up faster, calcine faster, and eventually fail sooner. So that's why you have to reduce the channel spacing, so you provide more support for the gypsum board to hold it in place longer during the fire. Similarly, if we increase the thickness of the insulation beyond 3.5 inches, regardless of where that insulation is in the cavity, even if we're still holding it up off of the gypsum board, we also have to keep the channels at a maximum of 12 inches on center. So this is the sort of interplay between acoustics and fire. And here's what this looks like in a UL design. Now, this is from L587, what gave us those examples from the previous slide. And I know in these, sort of presentations, you're not supposed to throw a bunch of text on a slide, but I've done it here to show you what it's like trying to read through and interpret one of these UL designs, because there's a lot of information in here, and you got to take your time to sort of parse through it. So we'll step through this with an animation. So when you start out, if your channels are at 24 inches on center, there's no insulation, right? Your channels are at 16, your insulation has to be a max of 3.5 inches thick and up to the subfloor. And then if you reduce your channel spacing to 12 inches, you can, drape your insulation over the resilient channels and ceiling, or you can have more than 3.5 inches. In this assembly, there's probably also like a 5A and a 5B. There's other options for other types of insulation, like blown-in cellulose and things like that. So it's all context dependent. So when you're figuring out your acoustical design, you can't just go in and say, oh, I need like a couple extra points in the IIC rating, add more bat insulation, because it doesn't necessarily work that way. And here's how that could kind of work out. So again, we'll reference the wonderful folks at NRC all of their great test data. So we've got a 2x10 wood joist assembly, very basic OSB subfloor, resilient channel, and gypsum board for the ceiling. So as Evelyn showed before, when you add insulation, going from an empty cavity to 3.5 inches of insulation, you gain about 8 points for both the STC and IIC rating in this. When you go to full cavity, you only gain an additional 1 or 2 points in this assembly. But from the fire example that we just gave, we know that oftentimes when you increase your insulation, you also have to decrease your channel spacing. So with no insulation in the cavity, we could have a channel spacing of 24 inches on center, typically. Again, it varies from UL design to UL design, even for the same basic structure type. But for example, say we go from no insulation, channels at 24 inches on center to 3.5 inches with channels at 16. So we gain 8 for the insulation, but we lose 2 to 4 points for reducing the resilient channel spacing. It's still a net gain of 4 to 6 points. So we're getting some benefit from putting insulation in the cavity. But when we go to the full cavity, we only gain 1 or 2 more points for the insulation thickness, but we also have to reduce the channel spacing again, and that loses us 1 or 2 points. So going from 3.5 inches to the full cavity fill overall is a wash acoustically because we've had to reduce the channel spacing. So that additional little couple extra points that we thought we might get to kind of bump us over that target that we were going for, we don't actually get it when we combine what we have to do for fire into that. So there we go.
So now we're going to look at some examples of stud gauge and stud spacing. We've got 2 walls here. They have different acoustic performances. They're both U465, and we have 18 mil 25 gauge steel studs, 24 inches on center, and also 12 gauge studs at 16 inches on center, a fairly significant decrease in acoustic performance. Just something to keep your eye on as you're looking critically at what wall you actually get in the design beyond just the UL number. So now we're going to look into kind of a sticky one. This is the 2-hour, one example of the 2-hour floor ceiling assembly, L511. It has a layer of gypsum board attached directly to the underside of the structure, and then it has a resilient channel and then an additional layer of gypsum board attached. That gives us kind of 2 strikes. Not only do we not have a resilient element between our gypsum board and our structure, but also we have a small captured airspace between the 2 layers of gypsum board, and that can give us some weird acoustic effects. It's unfortunately we don't have a lot of data on this assembly. Nobody's done much testing on it. It's not used very often. We know it's not great acoustically, and so there hasn't been a lot of focus. So I'm not going to cite a lot of test data here, but I do have some from NRC again. Here's that our standard 1-hour system with a single or something similar to a 1-hour system that has a single layer of gypsum board on resilient channels. We add that second layer attached directly, and we have a really significant reduction in both impact and airborne isolation. I've got another, here we're going to show you that if you go from the ceiling attached directly to adding that second layer on hat channel on resilient channels, you get a minimal amount of acoustic performance increase, even between those 2 systems. So what are our options? Usually we need a high level of acoustic isolation. They often put these 2-hour assemblies between a commercial space and a residential space, or an amenity space where they're expecting a lot of activity, and a residential space. Here's one option. You can connect springs through that fire-rated ceiling and hang another layer of gypsum board below. Again, we don't have exact performance here. We're not we're not given prescriptive answers, but this is certainly something that would significantly increase the overall performance of that system. Here's another example of a solution on the below side with clips, insulation in that cavity, and another couple of layers of gypsum board. Again, our point here is that these are fairly heroic additions to the system, both in money and effort. And finally, we have one where we've upgraded the top side of the acoustic, or of the fire assembly. So the fire assembly is below, and then we use a thicker sound mat, a thicker pour of gypsum concrete. This assembly gets us to about code minimum performance. But again, we're doing significantly more and paying significantly more than for a standard 1 hour rated code minimum assembly.
All right, thanks, Evelyn. So so far we've just talked about the individual assemblies themselves, but in an actual building, right, all of these assemblies are interconnected, and we have all of these intersections that we have to deal with. So how do we handle that? And again, as we've said before, rules of thumbs are dangerous and the devil is in the details. So I'm giving some examples here as things to think about, but you know, there's a lot of sort of jurisdictional variation in how you handle these things. They differ depending on the specifics of the project you're working on. So these are just things to consider, but again, reach out to the experts to talk through the details of how these work. So we'll start with wall-to-wall intersections in wood studs, and wood studs work differently for these intersections than do like steel studs. So on the left, we have a wall between two rooms within the same unit. So maybe between two bedrooms or a bedroom and a bathroom in a unit. So it's a non-rated wall for fire and really for acoustics too. But then horizontally, we have this this rated wall, maybe between the unit and a corridor. So for that wall, we need a fire rating and we need an acoustical rating. In wood studs, when we have this intersection, we can intersect the gypsum board of the fire rated wall with the wood studs that sort of frame the corner in the intersection for that non-rated wall. Sometimes this is referred to as like a 3-stud corner. And we can intersect that gypsum board with the wood stud because wood is typically used for fire blocking. It takes long enough for the fire to burn through it that it's a decent substitute for the gypsum board. So it's okay to do that here, to intersect a rated wall with a non-rated wall, or to intersect a rated wall with a rated wall like we have here on the right. And acoustically, the thing to pay attention to here is that we're addressing flanking paths, right? We don't have sort of continual paths from one side to the other. And in the one on the left where it's within a unit, that probably doesn't matter as much, but there could be some things like hospital rooms or maybe offices or something where you might run into this situation. But on the right, we care a lot more about flanking from unit 1 to unit 2, right? Because this is a demising wall and we want good sound isolation between these two separate units with separate occupants. And here we've addressed that. You got to make sure you pay attention to the details of, keeping your gypsum board back away, using fire and acoustical sealant, all of those. But when you pay attention to those details, it's fairly straightforward to address the acoustical flanking issues and maintain your fire rating at that intersection. When you get to steel studs, it's a little different. So in steel, you can't use the steel stud as fire blocking typically. So you have to do something different to intersect one wall with the other. So here we have an example where the fire rated wall and the acoustical wall, demising wall between two units, sort of bisects the lower side of the fire rated wall to the corridor. And you can do this because both walls are fire rated and typically they have the same fire rating. So typically these would both be 1 hour rated walls. But when you have a non-rated wall, like within a unit, you can't have that bisect the fire rated wall because it's non-rated. So then you have to do something like this. But the thing here is you have a flanking path because you have this continuous gypsum board. Now, again, if this is a non-rated wall from, you know, a bedroom to a bathroom or something like that, maybe we don't care too much about that flanking path. But if this were between units, then we would care. Or again, like maybe it's an office to an office, and we do care about that sound isolation between them. So if you have this wall bisect the fire-rated wall, like in the lower picture, that addresses that acoustical flanking path. But you then have to make that other wall fire-rated. And that can have significant cost implications, because on those non-rated walls, you might be using thinner gypsum board. You know, typically the fire-rated walls require, you know, 5/8 inch type X gypsum board or 1/2 inch type C, but you might use just, you know, regular 1/2 inch gypsum board for a non-rated wall. So you'd have to upgrade your gypsum board. That add costs. You're also going to have to use, you know, putty pads, fire pads, at electrical boxes. You're going to have to fire caulk any penetrations. You might even be required to run, you know, wiring and conduit. There's all of these other things that you have to do if you make it a fire-rated wall, and those are going to add significant costs both in terms of materials and labors. So you really have to pay attention to these intersections and how you're handling them. And we have a similar situation for a wall to a floor ceiling. So in wood construction, we can use a double top plate. We can use the wood of that double top plate, basically as fire blocking, to intersect that gypsum board ceiling, and we address our flanking path, whether it's within a unit or if it's outside of a unit. Now, there is also a flanking path here. I don't have it illustrated in an animation, but there is a flanking path for like impact sound, particularly from the unit 2 up above through the structure and into that wall below. And that's where isolation on the top side, like the gypsum concrete and underlayment here, can really help reduce that flanking path so that it's not an issue. When we get to steel construction, again, it's a little different because we can't intersect the gypsum board fire protective membrane with the steel studs. So we have to handle this a little bit differently. Here we have some blocking between the steel joists with an isolated backer to carry that top track. And in instances like this, they may actually have to come in and pre-rock this section of the ceiling above where the wall is going to be, and then you would construct a wall up to it and then come back and add your gypsum board everywhere else. When you do it like this, again, you have continuous gypsum board across the top of this wall, so that is a potential acoustical flanking path. Doesn't really matter if it's within a unit, but if it's between units, that can be an issue. And so, you know, one way to do that is to just sort of put a small gap in that gypsum board. You have to fire caulk it. You would kind of treat it like an expansion joint in your gypsum board. Again, all of these things, there are variations with local jurisdictions, how your, you know, code officials and building inspectors want you to handle these things. So again, not prescriptive designs here, but just things to pay attention to and details to look into. And with that, I think we're just about done.
We are, and we wanted to extend our thanks to the folks at Virtual who are running this. Matthew and Carol have been rock stars. Kristen Cody has shepherded us through this process as INCE's representative with really wonderfully. Obviously, our sponsors, PAC and Maxxon. Greg did of Oxia Design, did some review for us, which we really appreciated, and of course we special thanks to INCE, the entire organization, for giving us this opportunity to present this information. And I believe that we're going to open it up to questions now. Also on this screen, we have our contact information so that you can get in touch with us. But Mike, shall we just start at the top and go through these questions that we've been getting, and y'all keep adding them into it, and we'll just have a lively discussion.
Yeah, I think so. Let's go through it. I've got so I'll start in the Q&A. I see we've got some questions in the chat as well. So in the Q&A, first off from Lester, what frequencies would I need to prevent for between multifamily housing? And I pulled up a quote that I have in another presentation. So this is from the Blazier and Dupree paper in the Journal of the Acoustical Society of America in 1994. This is sort of a seminal paper on impact noise in multifamily housing. It's about a big lawsuit for some San Francisco condos. And Blazier and Dupree say the IIC rating of a floor system is meaningless with respect to the perception of these low frequency components of footfall noise because the methodology ignores the frequency spectrum below 100 hertz. So the frequencies you need to prevent for between multifamily housing is really kind of all of them, but a lot of times the low frequencies become the most important, especially in lightweight, wood or steel joist construction. And the IIC rating, we didn't go into it in this presentation, but the IIC rating stops at 100 hertz, but there's a lot of important stuff, all those thumps and thuds and booms that happen below 100 hertz. And to also sort of tie into the next question from Don about the HIIC. So we have two new metrics that address impact sound. So in the laboratory, we have the HIIC and the LIIC. And the H stands for high frequency. And so that's high frequency impact insulation class. And the L is low frequency impact insulation class. And the HIIC looks at the frequency range from 400 hertz to 3,150 hertz, correct, Evelyn?
Yes.
And LIIC, and that 400 to 3,150 hertz is already incorporated within the range that we look at for the IIC rating. But that particular range depends a lot more on your floor finish and underlayment. So you can better distinguish between those with the HIIC rating. The LIIC looks specifically at the impact sound in the 50, 63, and 80 hertz third octave bands. And that really depends a lot more on the structure itself, the amount of mass and stiffness that's in it, but also ceiling isolation can affect that and other various things. So I would really, look at all of those. And that's why working with an acoustician is really important, because they will often go beyond those single number ratings. They will get the actual laboratory test reports, and they will look at that third octave band data to see if it's really providing the level of performance in the frequency ranges that they think are important for that particular project.
Yeah, I think that answers the next question too. If numerically equal STC ratings do not perform the same or equally, how are STC numbers established? Oops, that's one question. And then the second is, if we are to propose another wall assembly as a substitution, which an architect may do based on the numerical STC value, how do we know we're making the proper substitution? And the answer to the second question is ask an acoustics consultant who can look carefully at the exact performance. The first question is that the STC and IIC, our hearing mechanism allows, they're called the equal loudness curves. We hear, it takes more energy at low frequencies to hear sounds at the same level as they are at high frequencies. So you can get away with more energy at low frequency than at high frequencies. And so we've established over time these curves that we then compare the measured data to, looking at, anyway, it's a little complicated, but we compare the measured data to these curves, come up with a single number. If you're really interested in the math of it, Mike and I would be happy to sit down with you and explain it all to you in great detail. But that's basically what it's doing, is it's comparing our hearing mechanism to the measured data.
Yeah, I also have a webinar on the PAC website that goes into IIC rating and STC rating calculations, and the HIIC and LIIC too, that goes through the curve fit and kind of how those come about.
So we have another question. Can you speak to the indoor air quality, VOCs or other emissions for gypcrete type products, as well as firecocks or other accessory materials? Is there a minimum recommended ventilation period prior to occupancy? I don't know that I've ever heard of that for fire sealants. Have you, Mike? They're usually such a small area. Certainly for gypsum concretes, gypcrete. We don't really, that's not something that's typically a problem. The gypcrete does have to dry in order to harden appropriately. And so usually you need good ventilation for that. So that would be, but there's not any specific minimum.
Yeah, I'm not aware of any of those kinds of things. I mean, there's like for the sealants and things, there's a fair bit of different manufacturers, and even within one manufacturer, there's a bunch of different versions, some of them for walls, some of them for ceilings, some are approved for, just acoustical sealants, some are for fire and acoustics, some are for fire and smoke and acoustics. There's a ton of different variability. So I think the thing would be to just look at the particular product and request the health product declaration or those kinds of documentations for the VOCs.
Yeah, and if I could add, all gypcrete products are Green Guard Gold certified, and we have tested all of our accessory primers and sealers for VOC. So I could definitely, I have made a note, and I will send that information out to the individual who asked the question.
Okay, great. Yeah, again, the devil's in the details, and you got to look at the specifics for that specific product, really, is where it comes to, and look for manufacturers that can provide that documentation.
So this next question is about penetrations affecting fire ratings and acoustical performance. I'm aware that fire stopping can be used for fire ratings, but how good is that for acoustical performance? And if I had a nickel for every time I wrote on a drawing, seal airtight with non-hardening sealant, I would be a very rich woman. So the airtight is key for acoustic performance. You absolutely want to seal everything up airtight. So the other thing is the non-hardening, because you don't want something that shrinks over time, because then you lose your airtightness. So those are the two kind of rules for sealing penetrations.
Yeah, and I see in our next question, architects often refer to the Gypsum Association Fire Design Manual, and in that fire design manual, at the front of it, there are a bunch of recommendations on sealing penetrations, and it addresses both acoustics and fire. So that's actually a pretty good reference. And a lot of the acoustics reference in there was written at least in part by one of Steve's former coworkers, Ben Schaefer, who at Quiet Rock Pabco, who's also an INCE member, participates a lot at NoiseCon and things like that. So there's a lot of good information in there for fire and acoustics. And the question says, a lot of architects reference the GA Fire Design Manual for both fire and SDC ratings. The problem with it is that the SDC ratings are often incorrect. Can you recommend a better resource? Right, so to give a little more on that. So one, the GA manual has been changing and improving, I think, over time, over each iteration. I think it's released every 3 years, right, Steve? In the latest versions, they have pulled out a lot of those designs that had incorrect SDC and IIC ratings, things like that, and especially in places where the assembly that was acoustically tested didn't actually comply with the fire design.
I think that was the key in that GA manual, was that they would do the fire assembly, but they wouldn't necessarily match what our entire presentation is about, the details of both of them.
Yeah, and they have been going through with a very fine-toothed comb and reviewing all of that and making updates, but there are still, I mean, I've found one or two recently that, slipped through the cracks, and because the screw spacing didn't actually match the fire design, for instance. So better resources. I mean, I think for the fire designs, the best place to go is to the actual UL designs. And typically the GA manual, I think, is a really good starting point, but it shouldn't be your end point. I will still use the GA manual as like a first point of reference to go like try and quickly find an assembly that has the basic building blocks of what I want. But then within it, it will reference typically the UL design. So then I will go to that UL design to find all of the details, the nitty gritty, and all of the different permutations of it to see, what different products and things are allowed in it and what's not. And then the ins and outs of, insulation thickness, channel spacing, gypsum board type, screw spacing, all of those things. And then for the that gives you the fire portion of it. And then for the acoustic portion, It's a little harder. I will really go to, typically it's manufacturers of the products that are in that design where you can go and look for test data. And so some of the manufacturers like PAC and Maxxon have online databases that you can register for, and you can get access to a whole bunch of the different tested assemblies. And so you can go to those places, and that's really the best because they have tends to have the most up-to-date testing. I know Evelyn and I referenced NRC, the National Research Council of Canada, in a lot of our presentation. They have a lot of really sort of good comparative data, but a lot of that testing was done in the like mid-90s. And, you know, things have changed, right? The way we manufacture gypsum board, the way we build things, all of that, like all of those different building elements have changed over the last 30 years. And so, you know, those tests are good sort of for comparative analysis, but they're not always the most representative of current construction.
So we've also got it looks like we've got a couple of questions about certificates of attendance, and Kristen Cody says that she can send out certificates of attendance. There's not a PDH set up for these webinars.
So I see, sorry,
we have quite a few questions that showed up in the webinar chat. Not
Yeah.
just the Q&A. So
we're getting
yeah.
ready to, we're going through those. They're let's see.
See,
So,
what is the reference for the quote? And I think they asked that right before you put it up in the animation.
Yep.
So that was the
like,
ICC G2 2010 acoustics guidelines. You can just Google it and you can find the full thing for free online. It's a really good reference put together by some very smart folks in the acoustics industry, many of them INCE members as well. So I would go check that out as a good reference.
Let's see, there is a question. I understand that wider screw spacing from the board edge was preferred for fire. I think that gets into where rules of thumb are dangerous. All of that depends on the exact fire assembly, and so we're gonna defer to the exact details of an individual fire assembly for that.
Yeah, and that's not my typical understanding. I mean, typically, like if you look at a wall design or a floor ceiling design, and I'm not sure, maybe there's some details of that question that I'm missing, but if you look at those designs, a lot of times the UL designs will specifically prescribe tighter screw spacing for the perimeter of the gypsum board panel and wider screw spacing in the field. So it might be, you know, 7s and 8s or something like that. So 7 inches on center around the perimeter and 8 in the field or something like that. But
again, each fire design is different, and that's really the final word on those sorts of things. We also have one. Do we know the break point of insulation thickness to keep the wider spacing? Yes, that's 3.5 inches. Going above that 3.5 inches clicks us over to to needing to reduce the spacing.
Typically, in 18-inch in open web trusses, it's typically 3.5 inches of insulation up to the bottom of the subfloor. A lot of 2x10 assemblies, I think, will specify like 3 inches, and it's just 3 inches period. There's not a min-max or something like that. And some open web trusses will say it has to be this. Like some of the more limited and proprietary designs are more specific and provide less variability. Some of the open web truss designs have an option with no insulation. Some of them just start with insulation. Some of them have no insulation and don't have options for adding insulation, except for like a few of the many different permutations. I-joists, because wood I-joists typically require 2 layers of gypsum board to get your 1 hour fire rating. There's often more flexibility with the insulation in those. Many of them will allow any amount of insulation as long as it's not directly in contact with the gypsum board and resilient channel. But, you know, make some rule and I can go find 2 UL assemblies that, you know, break that rule. So again, pay attention to the details, and it tends to differ by construction type.
Let's see. So we have a question for you, Mike, about resilient clips and spacing depending on insulation. And so I think
The
that
short
fits in with
answer
this.
is yes, but again, pay attention to the details in the specific assembly. So typically, the RISC clip and the other clips follow the same like channel spacing installation rules as the resilient channel in that same assembly. Now it may differ from assembly to assembly, but within one UL assembly, they tend to follow the same rules. Now, there are some exceptions to that. There are some differences in there. And there's also things like the ULIX, the lightweight gypsum board from USG, has some different channel spacing rules, especially within open web trusses and things like that. So there's a lot of little nuanced details. But generally, the clips and hat channel follow the RC spacing.
Next, I'm just going sequentially and what's in the chat here. My field experience shows that most contractors cannot screw the exposed layer without bridging the RC channels and hitting the substrate layer. With that short circuit, the benefit of the RC channel goes away almost entirely. Yes, agreed.
And that's why PAC exists.
So then the next one is, are you not concerned with triple and quadruple leaf assemblies when increasing the fire ratings of ceilings? I didn't see exactly when this came in. It may have been just as we started our 2-hour discussion. Curious if there's any testing available for these. There's very little testing. The answer is yes, having triple and quadruple leaf assemblies does change the acoustic rating. We talked about some double cavity wall assemblies that have some acoustically odd things that happen. Again, just lots of details that need an expert to look at all of the different permutations that are possible.
Yeah, and the basic concept there is that these small sort of constrained airspaces work as a spring, like air works as a spring, right? That's like what we have in our car tires, right? We're using the air to hold us up. It's this spring, right? And so the closer we put those two layers together, the more that air works as a spring and transmits energy from one side to the other. And we get what we refer to as a mass air mass resonance. And so the smaller that airspace is and the lighter our mass is, that higher that resonance is. And so a lot of times in acoustics, what we're trying to do is shift that mass air mass resonance down as low as frequency as possible, so we get it out of the frequency range that we care about. Now, sometimes we might do something completely different. Again, rules of thumb, right? But in these triple leaf assemblies, we try to increase that airspace. So that's why in some of those 2-hour assemblies, resilient channel is often the go-to, but that's only a 1/2-inch airspace, and you can't really put insulation in there, which sort of helps damp that spring motion. Some of those 2-hour assemblies will allow you to use like the RISC clip and hat channels instead, which gives you 1 inch and 5/8 air cavity. And sometimes you can put insulation in that cavity, so you get better performance. But then when you do something like springs, you get a much bigger cavity that shifts that mass air mass resonance really low, and you get better performance. Also, adding mass to the assembly in the terms of gypsum concrete on the top side or things like that can help shift your mass air mass resonance lower, or adding more gypsum board layers. So you play around with all of those elements. And as for testing, no, not yet, but maybe sometime Evelyn and I will get to that, because she has a lab
with our fancy new lab.
Yeah.
I think that so I'm gonna, as someone who works primarily on the top side of the assembly, I am going to throw out a rule of thumb that you can take with a grain of salt. But typically, I say that your spacing has to be 4 inches with insulation in it, and anything above that is going to it's going to affect things low enough that they're outside of where we calculate STC and IIC. And so that's kind of, you don't want anything, you want to aim for, if you're just looking for security, 4 inches is the minimum that I think that you can work with. So the next question sequentially was about where you can find the recording of the webinar. I just put it in the chat, the link in the chat. All of the webinars end up on the same page, and the recordings for the previous ones are available there. And so as soon as the one is available for this webinar, it will be available for there as well. Mike, do you want to talk a little bit about the direction of the fire test? That question was specifically about walls. Does the direction of the fire test matter, particularly for asymmetrical wall assemblies with clips or channels on one side?
Oh man, I was really hoping there wasn't going to be a fire question that would stump me. But you did it, Ben. So I think it does, and I'm wondering if Mike or Elzo is on here and has the ability to actually chime in on this one. So we may come back to that. I know that there are some things that matter for fire tests on asymmetrical assemblies, but I am not learned on the ins and outs of those. So let's save that one and come back to it.
Or we'll make sure that we get in touch with you separately, Ben.
Yeah. Yeah.
Let's see. So are there differences in fire versus acoustic requirements to seal gaps at the tops of walls or at sorry, we kind of already covered this. Airtight, permanently resilient.
But there are different requirements for the sealant that you use. So there are some that are approved, or I mean, there's less of an approval for acoustics. There's more of an approval for the fire rated ones.
Right.
So look for that, but then also look for one that's for acoustics, ideally one that's got some test data behind it. And you want non-hardening for acoustics.
Yeah. I generally say anything that's plus or minus 25% movement after curing is considered permanently resilient in my book.
And I think that there's an ASTM standard for that too. It's C919 or something like that, I think.
Yeah. All right. So now we're getting into the good stuff. Here's a question from Ben Lotion. How would you explain the poor low frequency performance of the double stud shear wall cavity resonance question? If so, could the shear walls be moved to the outside of the studs to create a larger cavity? I think that's a combination fire. Okay, so
yeah, yes
sold.
and yes. The trick with that, and we've been dealing with this on a lot of projects recently, is that if you move those shear panels to the outside, that works well acoustically, works much better acoustically, and it still works fine for fire. There's a general provision within the UL designs for walls that you can put, a plywood or wood like shear panel behind your fire protective membrane. That's okay. Typically, again, rules of thumb. But the issue with that is typically you put those shear panels up when you're doing the framing. The framers do that, and then after the framers come your plumbers and your electricians, and they're not going to be too happy when there's a big plywood panel covering up the space where they've got to run wires and pipe and all that kind of stuff. So it presents a lot of challenges for running MEP and for phasing all of that stuff within construction. So that's where, like, acoustically and fire we're all good, but from a construction standpoint, the contractor is going to be cursing you. And so on sometimes we'll leave one panel on the inside and then shift the other one to the outside, which makes it not quite as bad. But there's other ways to deal with it too. You can add clips on one side and things, and we've got some test data in our database.
So I think this is our. Nope, we've got one other question over in the questions, but Pablo asks, will you test for and publish the natural resonant frequencies of the various acoustical mats under the typical gypsum concrete layer thicknesses, as well as for the various resilient isolation sealing products loaded with 1 and 2 layers of gypsum wallboard? For you, Pablo, the world. We may ask for your help on how exactly you feel the best method for testing those natural resonant frequencies is, but that's a really great conversation to have.
Yeah, would you like to help develop an ASTM standard for how to measure those? And actually in that, at the last ASTM meeting that just happened last month or earlier this month, whenever it was, I think Jordan Strybos at Intertech proposed starting a working group for a new ASTM standard to look at a specific measurement for underlayment specifically, right? And so
yeah, but that was
it's not about like resonant frequency, but I mean, it's all like very fresh. It's just like, hey, we should start doing this. So
yes.
that
So
could factor into that.
So we did, in fact, get a yes from Pablo. So we'll see you in Chicago or Grand Rapids, and we'll talk about it over beers.
We'll discuss. And for the ceiling isolation, yes, I think that's an interesting thing. Again, let's talk and figure out a good way to do that.
All right, so back in the Q&A, for STC ratings, does taping the first layer in a multiple layer wall or ceiling assembly improve STC ratings? If it does, is this measurable? First of all, everything you change in acoustics is measurable and makes a difference. The question is it big enough to worry about, and does it actually translate to the field?
Wait, is it really measurable? Let's
so my understanding in talking to someone who's runs a wall lab recently is that they only tape one layer, and they find that if they tape both layers, that it doesn't actually give them any difference, that as long as they tape one of the two layers, that it doesn't matter. So I'm going to call it in this case, no, you don't need to tape both layers.
The caveat that I would give to that is that I know the lab of which you speak, and I know that they build things perfectly.
So for insurance,
that
you do
one
want to tape
layer
both.
taped is going to, everything will be airtight and will be sealed very well, because it's a lab, it's a controlled environment, and they're not trying to get it done as quickly as possible so that they can get their paycheck. They're trying to get it done exactly right so that one of us doesn't tell them they have to do it again. In the field, things work a little differently. So I think, you know, doing both layers might provide you some extra assurance. There's extra cost for that, materials and labor, right? So there's a balancing act. But I think if it's a critical space, I would probably go for just sealing both layers just to make sure that there aren't any gaps or areas that get missed.
The next question is, are fire ratings determined by architects, or is it a sub-consultant? Do you ever interact with those fire rating designers, and at what phase should those conversations happen? I always think that those conversations should happen as early as possible.
Early and often.
Early and often.
In my experience, it is typically the architects that are picking the fire rated assemblies and doing the fire design. On more complicated projects, like that hotel over a parking garage that I mentioned early on, I think there was specifically, like, you know, there are a lot more consultants, you know, focused on specific niches that were working on that one. So, you know, I was the acoustician. I think that there was a fire protection engineer specifically working on it. They had the, you know, the more technical architects, like from the architecture firm, highly involved in that. There are the structural engineers and all of those kinds of things. So it depends. If you're just doing typical 1 hour, you know, demising walls and floor ceiling assemblies, you typically go to the GA design. You know, the architect typically goes to the GA design manual, or, you know, UL, and picks an assembly. Or some jurisdictions like LA have prescriptive designs for walls and floor ceiling assemblies. When you get into the more higher performance or funkier assemblies, I would reach out to a specific, you know, fire protection engineer and do it earlier.
So Neil Shaw asks how to seal at fluted steel decks. The
GA manual actually has details for that.
Do they have details? Because I was going to say that I have seen a couple of different ways.
So they have details for it, and I think those also reference probably UL head of wall details. So it's going to depend on if it's a static or a dynamic joint. A dynamic is going to be where you have a deflection track, and you have to account for that within your fire rating. A lot of times in those, you'll have some sort of intumescent or something like that. That's an expanding material when it gets hot. So it allows for movement, but then seals when there's a fire. But yeah, the GA manual has those, and I think they reference specific UL designs. But I'm looking in here, like They're the SRS towards the back of the GA manual, the strain relief systems. You will see some of those. A lot of those are maybe deflection heads, but that would be the sort of go-to place.
I've
ahead.
also seen in non-fire rated assemblies, I mean, you know, either cutting the gypsum board and sealing around it, which is labor and time intensive, but also there are, I've seen mineral fiber pucks that are shaped to fit the flutes, and you fit those at the top of the wall head and then seal with a trowelable sealant that's non-hardening, that really with a trowelable fire caulk. I don't know if that's in the GA manual.
Yeah, there's also
Mike,
like steel straps and you know, maybe again filling the flutes with mineral fiber and then putting some sort of cap over them that then you butt your wall into. And that cap might be, I think, maybe a steel plate or also gypsum board. So there's some options, and yeah, they're in the GA manual, and there's also UL designs of head of walls. They typically start with HW and then something for head of wall.
Although, Neil, I have to say that I'm going to buy you a drink next time I see you. I'm sure you have thought of 3 or 4 other methods that Mike and I did not.
Probably, I'm sure, yeah. I see Steve got the link to the consultant login. Evelyn or Heidi, y'all should put yours in there too, because you've got a new updated version of your database. That's really great.
Yes, right.
And Greg says field constructability is a key difference between assemblies with similar STC ratings. Yeah, I think that's a really good point there, Greg, and that's something that we look at a lot, right? Is not just like what's the laboratory rating when, you know, something was constructed by the lab in a controlled environment, but how likely is it to come close to that level of performance in the field? And there's a lot of different things that go into that.
And Mike Dickerson wants to know, what do you recommend for Maxxon over large span metal joist floors that tend to flex? Whew, that's a, I think, Mike, how about if you and I have a call later on and discuss the exact specifics of what you're looking for? That's a big can of worms there.
Yeah,
I'm not sure I have a quick and easy answer to it. So we'll chat later.
Yeah, that's a good question though, Mike. I'm not seeing any more questions. Oh, nope. Gerald, any thoughts on smoke and acoustic track seal products such as Hilti, CSTTS prefabricated joint products? I think the short answer is no. I'm not particularly familiar with that. Acoustic track seal products. Yeah,
No.
that's one I'm just not particularly familiar with.
Well, thank you. We'll look into it.
And I do realize that there was a question from Ben Seep that we didn't get, and that was about the asymmetrical walls and the fire tests. And I don't think that I've gotten any messages separately from Mike or Elzo. So Ben, I will have to follow up with you on that one. And I don't know for the INCE folks, like I know for the first webinar, there was a separate, like a PDF document that was there with the Q&A, and in both of the videos, the Q&As were posted, so you could go back and reference those. Is there any way that we can, like, if I get the answer and I follow up with Ben on that particular question, is there some way that we can post that answer where the other folks going and viewing the webinar or whatever can see it, since we didn't have an answer for it here?
Yes, Mike, this is Carol. Yes, we can post the answers along with the webinar recording.
Okay, awesome.
Yeah.
Sounds good.
Great. Thank you all for such good questions.
Yeah, this has been really great. And again, thanks to everybody from Virtual and INCE for putting this on. Thanks to Steve and Heidi for coming up and joining us on this. And
Thank you, everybody.
And thanks to Greg for reviewing our slides for us.